All right, I hope everyone had a good weekend. We are going to continue what we were doing last time, and I know some of you weren't here, and I had I guess a technical problem with the video, so there is no video of the last class, and I apologize for that. So our goal today is to continue solving quadratic equations. Our next exam is not this Wednesday, but next Wednesday. All right? So I believe that's on the 3rd, April 3rd. All right? So let's try and get through as much as we can the next 2 days, and that way maybe we can spend some time on Monday reviewing. All right? So our goal today, and probably part of tomorrow or next class, is to be able to solve any quadratic equation. Okay, any quadratic equation that anyone ever gives us, we want to be able to solve it. So just to be clear, what are we talking about when we say quadratic equation? We're talking about any equation that looks like this. That's a squeaky marker. All right, so we want to be able to solve any equation that has that form. Here are some examples, specific examples of quadratic equations. And we've been looking at these. 2x squared, let's say minus 5x. Let's go with plus 2 equals 0. That's an example of a quadratic equation. What makes it quadratic is the x squared, right? We talked about this. And the equal sign makes it an equation. So we want to be able to find the x's that make that true. And what we talked about last class was that when we have linear equations, it's pretty easy to move things around. But when you have quadratic equations, what did we have to do from last class? You remember that? What was I saying for last class? To solve a nonlinear equation, remember, we had to move everything over to one side and factor, right? That's what we were doing last class. We'd move everything to one side and factor. So this is an example of an equation that we can do that with. Here's another example. Okay, does everyone see that that is also a quadratic equation? And that if you moved everything over to one side, then it would look like this, right? So let's just take a moment to see if all quadratics look like this, then can you tell me in this equation right here what A, what B, and what C are? So A is always the number in front of x squared, B is always the number in front of x, and C is always the number by itself. So what would A be for this problem? 2, right? And that's that 2 right there. And then the B would be what? -5, that's the number in front of x. And then the last number, C, would be this 2 in the back, right? It's important that we identify these because of where we're going. All right, what about this one? Can you identify A, B, and C here? And you have to be careful. So 5 is in front of x squared. Y'all agree with that? Okay, but what about B? It's not 3, it's -3, and the reason is because it has to look like this first. So we'd have to move the stuff over to one side first. So if I move things over, I'm not going to show the work for this. I'm going to trust that to get from here to here, you would subtract 3x on both sides, and then you'd add 1 on both sides, and then you'd get to this. So it must look like this before you can identify A, B, and C. So what's B then, we said? -3, and then C would be +1, okay? So this will be useful for us in a moment. I just want to make sure you understand that all quadratics look like this, and then you can make them, no matter how they're given to you, you can move everything over, and then you can identify A, B, and C. All right? Okay, now, that's our goal. But before we get to actually the kind of new stuff today, I need to do a quick review of radicals. So this is a review here of what we call radicals. Okay, so when you see this, what does that mean? The square root of 4, right? And what is the answer to this? What is this equal to? Okay, so what we're saying, when we see this symbol on top of 4, we're saying, what number do we square in order to get 4, right? So this number times itself, 2 times 2 would give us that number 4. And we can do this for all the real common roots, like 9. What's square root of 9? That'd be 3, and then, let's see, what's the next one we should know? 16. Square root of 16 would be 4. Oh yeah, square root of 1. What's square root of 1? 1. What's square root of 0? 0. Right? What number times itself gives you 0? 0. 0 times 0 is still 0, right? So these are these, 1, 4, 9, 16. The next one would be 25. Those are the ones that we should know. Square root of 25 is 5. Square root of 36 is 6. What's one after that? 49. Square root of 49 is 7. 64. Okay. So those are our common square roots. Now what about something like this? Square root of 12. So that is not, you're not going to be able to sit here and tell me what number squared gives you 12. Like, there's nobody in here should be able to do that in their head. However, we have calculators, right? So make sure on your calculator, okay, you can type this in, you can get the square root of 12. And I actually put new batteries in my calculator the other day, so I'm pretty excited about that. I'm getting on my calculator approximately, so I'm going to change this equal sign to a squiggly equal sign, which means approximately 3.46. I'm just going to round it 2 decimal places. So this is an approximate answer. It's not exact. It's approximately 3.46. And that means that if you take 3.46 and multiply it times itself, 3.46, you should get an answer that's really close to 12. And I get 11.97, which isn't that close, but again, this was an approximation, right? All right, so this is the approximate answer. That right there is the approximate. I'm just going to put approx. Okay, but there's another answer you can get, which is called the exact answer. And this I'm not going to take too much time on in the class, because really I'm going to want the approximate more than anything else. But you may have seen this before, that if you can't come up with the number like we did over here, okay, if you can't do that, then what you can do is you can try and see if there's a way to break 12 down. So can you think of 2 numbers that multiply to be 12? 2 different numbers. 6 and 2, 3 and 4, right? Try and come up with 2 numbers where one of them is one of these. Okay, so like think about 4 times 3 would work, right? 4 times 3 is 12. Now, there's a property of radicals that says if you have multiplication underneath a radical, you can split this into 2 radicals, like this. So it splits up. And now, what is the square root of 4? 2. So this becomes 2 times root 3. So this is like a simplified version of that, but it's the same answer, all right? So I'm not real big on going from here to here, because they're exactly the same thing. They're exactly the same numbers. But just be aware as we're working through these, if I do something like this, I need to make sure that you understand what I was doing, splitting it up. Let's do one more of those, just to make sure. What would be the square root of 180? Let's see if we can, first of all, let's find the approximate answer. What is it? 13.4? Okay, good enough. 13.4, good enough. All right, that's our approximate answer. By the way, I didn't tell you, this is called the exact answer. I should probably put that here. That's the exact. But say this is also the exact answer. They're the same thing. because we're not using a calculator to round. We're giving you what the exact answer is. It's square root of 12. So what could I do here? With 180, could I break it down? And you want to try and break it down to two numbers where one of them is on this list of common, the common radicals. Square root of 25 is 5. Square root of 36 is 6. So can you think of a number that is a perfect square that goes into 180?
6. 2 times 9. That's what I can.
What's that?
2 times 90.
90? Okay, so 90 is not a perfect square, is it? Right, 90 is not? I heard 6. 6 goes in there, 30 times? But neither one of those is a perfect square.
What about 5 and 36?
5 and 36? Does 5 and 36 work? I was thinking 9 times 10, because 9 not 9 times 10. 9 times 20 would work, right? 9 times 20? Or you said 36 times 5. So let's see, what if I did 9 times 10? I said it again. 9 times 20. Do y'all agree that that's 180? Yeah. Okay, and then someone else said 36 times 5. This one's real nice because this one splits up square root 36 times square root of 5. And the square root of 36 is what? 6. Okay, 6 root 5. So we would be done here because 5 can't be broken down any further. Now here, we split this up, root 9 times root 20. This becomes 3 root 20. Y'all agree? But 20 can be broken down. 20 can be broken down how? Try and use one of these. 20. 5 and 4, right? 4 times 5. So what you could do here is go 3 and then square root of, we said 4 times 5 is 20, and then break the 4 and the 5 into 2 roots. 3 times square root of 4 times square root of 5. And what is the square root of 4? 2. So this will become 3 times 2, root 5, which would be 6 root 5, which would be the same answer, right? Do y'all see that? Like I said, I'm not real big on this, but just be aware later on, if I'm doing simplification, I might do this, all right? All right. I do have to bring this up. What is the square root of negative 1? Remember what this means, okay? Look, when you say the square root of 4, everyone said that was 2, right? And the reason why is because when we take that 2 and we square it, what do we get? We get that number 4, right? Yes? So if I say square root of 9, everyone says it's 3, and that's because 3, when you square it, you get 9, right? Which is that. So when you're looking at this square root of negative 1, you're saying to yourself, what number do I square, right? What number do I square to get negative 1? What's wrong with that? What's wrong with that idea? The whole idea here. If you square a number, it should be positive, right? Think about any number you pick. If you multiply it times itself, it has to be positive. Because, well, just think of any two numbers, right? If I take 5 times 5, that's got to be 25. But if I take that number and make it negative, negative 5 times negative 5, as long as these are the same numbers, that's still going to give me positive 25. So whatever number you pick here, if it's a positive number, when you square it, it's still positive. If this is a negative number, when you square it, it should be positive. So it is impossible to make this happen. Agreed? Do y'all agree with that? And therefore, anytime we see a square root with a negative number under here, there is no real number answer. There is no number that we can come up with that would be an answer to this. All right? Now, there is a way to do it, but we're not going to mess with that. In this class, we're not going to mess with it. It has to do with imaginary numbers and We're just going to stay away from it. What we need to know is that when we see a negative underneath the square root, that it's bad. Okay, that's not a good situation. All right. So now let's get back to our ultimate goal today, which is to solve any quadratic equation. All right, so here's basically the procedure we're going to use to solve any quadratic equation. Okay, first step is to write the equation in the form ax squared plus bx plus c equals 0. In other words, move everything to one side. All right? That's the way we're going to start solving all quadratic equations. We're going to move everything to one side. All right? Now we have a couple of things that we want to look at. So second step, if b equals 0, then use what's called the square root property. Now, we haven't talked about the square root property. I have not shown you that yet, all right? But I'm telling you that if we're trying to solve a quadratic equation and we move everything over to one side and that number right there is 0, then we're going to do something very special, all right? If that number is 0. Third step, if b is not 0, okay, if b is not 0, we're going to do one of a few things. We're either going to A, factor, or B, use what's called the quadratic formula. Now, we did this last class. We did that. We did factoring last class. So there's kind of two new elements today. We have this special case, and we have the case where we can't factor, we can't figure it out. We go to this using the quadratic formula. And I've not talked about that yet, all right? So let's start with an example and see where it goes. Bless you. All right, so here's your first example. Let's say we have 3x squared minus 24 equals 0. Is that a quadratic equation? Bless you. Is that a quadratic equation?
Yes. No.
What makes things quadratic? What is it that we're looking for? X squared and, very important, you got to have an equal sign, okay? Equal sign and an x squared, and it is quadratic, all right? So that is a quadratic equation. The first thing we're going to do is write it in this form, which means we're going to get everything to one side and a 0 on the other side. Do we have that yet? Is everything on one side with a 0 on the other side? Yes? So step one, we've got, right? We've got everything to one side. Now, can you tell me real quick by looking at this, can you tell me what A, B, and C are? So A is 3, the number in front of x squared. B is the number in front of x. And there is no x, right? Which means there's a 0 in front of x. That's important. If you don't see an x, that means there's really like, it's kind of like someone really wrote 3x squared plus 0x minus 24 equals 0. That is the same problem as this problem because that's really not there, right? So this is the case where you don't have, when you're missing an x, that's the case that b is 0. Make sense? And then what's c for us? Negative 24. Okay, so we have a quadratic equation. Everything's moved to one side. If b is 0, we're going to use the square root property. B is 0, right? So let's talk about the square root property, because I haven't done it. Step 2. B is 0, right? Yes. So we're going to use the square root property. So here's how the square root property works. All we do is we write the equation down. And we're going to do this kind of like a linear equation. We're going to try and get x squared by itself on one side of the equation by itself. So if I want to get x squared by itself, the first thing I'm going to do is move this over. I know that seems weird because we started the problem by moving everything to one side. But if b is 0, you're always going to want to get x squared, whatever that square term is, by itself. So I'm going to add 24 to both sides. Do I need to show that step, or am I okay just writing that? Is everyone comfortable with that? Add 24 to both sides? We're okay? Now what? I'm trying to get x squared by itself. So what can I do on both sides? Divide by 3 on both sides, right? So divide 3 here, divide 3 here. And what do I get? X squared equals 8, right? Right? 24 divided by 3 is 8. X squared is by itself. And now we know what x squared has to be, right? We're trying to figure out what x is. What we know is that x squared has to be 8. So now this is the square root property thing. What we do here is we take the square root on the left side and on the right side. And we get our answer. When you take the square root of something that's being squared, they essentially kill each other off, and all you're left with is x. And on this side, we have square root of 8. But that is not correct yet. That's not correct. You have what? You don't have to simplify. I'm missing something more important. Let me try and motivate this with a just forget that for a second. If I tell you that some number squared is 4, what number am I talking about? 2, right? 2 squared is 4. Is that the only number that you square to get 4? I agree 2 squared is 4. Yes, I agree. But what other number could I square and also get 4? Negative 2, right? Negative 2 times negative 2 is also positive 4. So when you have x squared equals 4, there's actually 2 answers. 2 and negative 2, right? Here, when I had x squared equals 8, I should get 2 answers for the same exact reason. One of them is positive, the other one is negative. So when we do the square root on both sides, like that, when we do that, we have to remember to put plus or minus. Plus or minus. And that means that there are 2 different answers. There's a positive answer and a negative answer. So our 2 answers are this: square root of 8, or x is negative square root of 8. Does that make sense, the plus or minus right there? 2 separate answers. And that's it. Those are our exact answers. And yes, you could break the 8 down, but on a test, I would take that as an answer, and I would be completely happy. Now, just so we can practice, let's get that as a decimal. 2.83, let's say. X is approximately 2.83, or x is approximately negative 2.83. Those are our, pardon?
Sorry, when we do like the quiz or the test, are you going to want both answers, or can we just do x equals and then plus or minus?
You could do plus or minus. Yep. The reason I'm showing you the 2 answers like explicitly written out, because I just want to make sure everyone understands there are 2 answers. The plus or minus means 2 different things.
Gotcha, I just want to make sure.
Yep, I would be fine if you just put, if on a test, if you put x is plus or minus 2.83, I'd be okay with that. If I was asking for an approximate answer, or just that answer right there would be fine. Okay, so just to recap, we're trying to solve a quadratic equation. and we're missing the x term, right? The x term's missing. We solve it very much like a linear equation, except at the end we have to do square root on both sides, and that will create two different answers, all right? Questions on that? We'll do one more. How about this one? How about 1/4 x squared equals 5? Let's see if we can do this a little faster than the last one. Is this a quadratic equation? Yes? You see x squared? You see an equal sign? Yes? Okay. Is this one missing the x term? Yes, it's missing the x term, right? And that means b is 0. We could do it. We could move everything over to one side right now and we'd be able to see that b is 0. But can you look at that and just know b is 0? Okay, so I'm just going to make a little note here. B is equal to 0 here, all right? If b is 0, my goal is to get x squared by itself. And it's already almost there, right? Do you see that? Do you see that all I have to do is get rid of the 1/4? All I have to do is get rid of 1/4 here. I already have this 5 is already on this side. So what could I do to get rid of 1/4? I could multiply by 4 or divide by 1/4. I like multiplying by 4 here. So I'm going to take 4, multiply it on the left side, 4 multiplied on the right side, and that will clear that fraction out. All you'll be left with is x squared equals what? 20. And then the very important next step, square root both sides, right? And when you square root both sides, you must remember now to have plus or minus here, right? Plus or minus. Don't forget the plus or minus. So x equals root 20. Plus or minus. So, you know, when I'm teaching this class, when I'm teaching the 13, 14 class like this, and I say, you know, don't forget the plus or minus, I say, what happens if you forget the plus or minus, right? You get a few points taken off the test, right? In my 14, 14 class, I stress to them that these are the types of mistakes that, you know, make bridges fall and planes fall out of the sky. And I know that that's kind of extreme, but I mean, we've had an airplane, right? You've heard about that Boeing 737 Max, the one that they grounded. You know what I'm talking about? 2 of them have like fallen out of the sky. Yeah, they grounded them. Yeah. Apparently, it's I don't know this for sure, but I think it's like a sensor. There's a sensor and there's a software glitch. So there's a sensor on the plane that it's like a little wing, a tiny little wing that sticks out on the front of the plane, and it can tell whether or not the plane is stalling. So it sends a signal to pull the nose down, okay, because it thinks that the plane's doing this. So that sensor's bad or something with the software. So basically what's happening is it's taking off and it's flying, and all of a sudden the sensor goes bad, the software has a glitch, and then dives the thing into the ground. I know that plus or minus doesn't seem like the same sort of mistake, but these are the types of things that you have. I mean, these are little things, but they're big things if there's a lot more at stake. Does that make sense? Like if you forget plus or minus, you're missing an entire solution here. There's 2 solutions. You're missing one of them. And that could mean the difference between a plane falling out of the sky or not. So it's not important here, but in the big scheme of things, those are the details. All right, we good with that? Let's try something else. Let's try another quadratic equation. Let's do that first one I had up here. I'm going to kind of change it up a little bit, though, make it look a little different. How about this one? 2x squared plus 2 equals 5x. So first of all, is that a quadratic equation? is b 0 this time? B is not 0 this time, right? Because you have an x term. As long as you have an x term, b is not 0. So what I'm going to do, I move everything to one side first. So when I move everything to one side, I subtract 5x here, I subtract 5x there, and then where am I going to put that minus 5x on the left side? You can't combine it with these, right? You can't, like, 2 minus 5 is negative 3, right? You can't do anything because they're not like terms. So you're going to have 3 terms. What order are you going to put them in? Go ahead. Oh, no. Okay, so we call that descending order, but that's the order that our general form needs to look like, right? ax squared plus bx plus c equals 0. So quickly here, just so we are aware, what's a, what's b, what's c? So a is what? 2. We did this already. Negative 5 and 2, right? So it's obvious from that b is not 0. So if b is not 0, how do we solve this? We have 2 choices, right? Factoring or quadratic formula. Quadratic formula, but we haven't talked about it yet, okay? So let's try factoring. Can we do this with factoring? So you look at this and you do that thing that we did last class. You try and factor that trinomial. So what number do I put here and what number here? 4 up here and negative 5 here. So you have to come up with 2 numbers that multiply to be negative 4, but add up to be negative 5. Negative 4 and negative 1. And then you go through and you do what we did last class with the grouping, right? So I'm going to do this. I'm going to take this the whole way. I'm going to go 2x squared. I don't touch that. I don't touch the 1 in the back. Equals 0. So I'm just rewriting the equation. That middle term, negative 5x, how am I going to rewrite that? It's not going to be negative 5x. It's going to be what? Negative 4x and negative 1x. So you're using those 2 numbers to be able to break that negative 5x up. All right? Now we group. So right after the first 2 terms, you slash it. And what can we pull out of that first 2 set of terms there? A 2 and an x, right? So we pull a 2 and an x out. So if we pull a 2x here, what are we left with in there? X minus 2. So 2x times x, 2x squared, 2x times negative 2 is negative 4x. And this is where we kind of played that game where I said, why don't you put down what you need here, right? Let's try and see if we can come up with that number right there. And I said put a plus here. So what number would I need there in order to get from here back to here? I need my x to turn into a negative x and my negative 2 turn into a positive 2. We need a negative 1 out here. And then equals 0. Don't forget, you still have an equation. What's the next line I can write at this point? Since these match, it's going to turn into the two things, right? Like that. X minus 2. And then 2x minus 1. So once we're here, what do? We have factored it, right? What do we do at this point? This is what last class was about. If you have 2 things that multiply to be 0, that means that one of them has to be 0, right? So this is where you take these and you set these both equal to 0. So I take x minus 2, set it equal to 0, then I do a separate equation, 2x minus 1 equals 0, and I now need to go and solve those 2 linear equations. So this one we just add 2 to both sides, we get x is 2. And here we're going to move the 1 over, then divide by 2. So I'm not going to show that work, I'm just going to trust that you can get to that. Add 1, divide by 2. And so those are our 2 answers, right? To solve this equation right here, if you plug 2 in for x, you should get a true statement. This side should equal this side. Or if you plug in 1/2 for x, 1/2 for x there, you should get a true statement. We're not going to check it, but that's what we've done. All right? Now, let's change the problem just ever so slightly. I want to go back up to this. I'm going to give you a new problem. I'm going to change that 5x right there to 7x. And let's try this one. Let me think about this. Yeah, we're good. All right, so same set of steps. First thing, is it a quadratic equation? Yes. Is b 0? No, b is not 0. So let's move everything to one side. So the first step, we get everything over to one side. What's it going to be? 2x squared minus 7x plus 2 equals 0. So now if we list out what a, b, and c are, the only thing that changes here is that this is minus 7 instead of minus 5, right? That minus 7 is going to have a huge impact on things, though. Huge impact. Because now when I try and factor this, I have 4 here and I have negative 7 here. And that ain't happening, okay? You're not going to be able to come up with two numbers that multiply to be 4 and add up to be negative 7, all right? Now, does that mean that they don't exist? It does not mean they don't exist. It just means that our brains aren't capable of coming up with the numbers. We can do this so long as these numbers are nice numbers, integers, like 4, negative 1, something like that. But if these are like some weird fractions or something, we can't figure it out. Our brains just don't work that way. So we are stuck. So factoring here fails, right? Factoring fails. But look at what the goal of today is. Solve any quadratic. And right now, we are at a point where we've run out of things to do. We don't know how to handle this. But fortunately for us, and on your list of steps, what did I tell you? You could do factoring or what? Quadratic formula. So let's take a break here. Let's pause this. That's a pause button. Okay, we're going to come back to that. It's impressive. That looks exactly like a pause button. No one's going to argue with me about that. Let's talk about the almighty quadratic formula. All right, here's the quadratic formula. If you ever have a quadratic equation like this, so you must have a quadratic equation to use the quadratic formula. If you're ever looking for the answers to that, you know, what x you plug in to make that true, then here's what the x is. The x's, the answers to this basically, are negative b. So whatever that number is right there, you just take the opposite of it. So if that's 5, that's negative 5. If that's negative 5, that's positive 5. So just the opposite of that number, plus or minus, which means you're going to have two answers. The square root of b squared minus 4 times a times c, all of that divided by 2 times a. And that is the formula. I know a lot of you have seen that formula before. What this is saying is some mathematician in the past tried to figure out a general answer for this. If somebody gives them any quadratic equation, they wanted a formula that would spit out the answer without them having to do any work, really, other than just plugging numbers in it. Notice that all this is, all you have to be able to do is identify A, B, and C. Once you know what A, B, and C are, which we know, right? Then all you can do is plug in B, B, A, C, A, and then that'll be a formula for the answers, and there will be 2 of them, all right? Now, I'm not going to prove where this comes from. You just have to believe that somebody went through the work to show it's true. All right, so this is extremely powerful, and now we can use that. Do you have a question? Yes. Go ahead.
No.
Come on. Do it. No?
No, I'm good.
You sure? Is he good or no?
Yeah, he's good.
Okay, all right. No, do it.
So So if we can use that instead of factoring or the other way, just use that.
Okay, so that was going to be my next point. If this works for any quadratic equation, then why not just use this every time, right? Right? Okay, I agree. Okay, you can. Here's the only drawback to this equation is that sometimes it's just easier and faster the other way. Like for example, the problem that I gave us in the beginning, the first problem I gave us, 3x squared minus 24 equals 0. Right? This one right here, b is 0. So I don't have an x term. So I move the 24 over. I divide by 3. I take the square root, plus or minus, and I'm done. That takes me about 20 seconds tops. If you use a quadratic formula for that, you're going to be there for several minutes doing that, I think. So it's just, it's less efficient. This is less efficient sometimes than something like this. Does that make sense? Or if like the one we did before this, if you can factor left-hand side, I'm kind of with you on that one. That would take a while. And so maybe the quadratic formula is better. So I'm not really, on the test, I'm going to ask you to be able to factor. So like you're going to have to prove to me on the test that you can factor. But when it comes to quadratic equations, I'm not going to tell you you have to do it a certain way. I just want you to get to the answer. All right? So if you want to use this, just keep using it. Just go ahead. But it might take you a little more time to get through some of the problems that are going to take someone a lot less time. Does that make sense? Okay, so here's the formula. And we are now going to use it over here because we were stuck, right? All right, so let's come back to this. Factoring fails. Now I'm going to use a quadratic formula. So I'm just going to write QF for quadratic formula just to make sure that you understand what I'm about to do here. So for the quadratic formula, we're going to go straight to the answers. X equals. And now we needed to identify A, B, and C, which we already did, right? Now the first number that goes here is negative B. And what is B for us? It's negative 7, so we're going to take the negative of negative 7, which makes it positive 7. So it's this right here is always the opposite of your B. So for us, that's 7. Plus or minus. Now this next part, B squared. It's our number B times itself. So what is negative 7 times negative 7? 49. And it will always be positive. Won't that B squared always be positive? Yes? 49? So square root 49. You have this disgusted look on your face. Are you all right? Oh, no. Both, you're all right? Both, everyone?
It was just when you said the opposite. I'm like, oh, that's not cool.
Yeah, it's just the opposite. I mean, it's negative. Negative means the opposite. So look at that right there by itself is negative 7 for us. But then we're changing the sign. Okay, so here's where we are. We've done B squared, right? Minus 4. Now I'm going to multiply 4 by two numbers. So I like to put those in parentheses. I'm going to go 4, and then I'm going to go times A times C. So what goes in for A? 2. And then for C, 2 again. So 2 here, 2 here. I'm not going to multiply those out yet. And then on the bottom, I get all of this, the entire thing divided by 2 times A, but A for us is 2. All right, that is the quadratic formula with everything plugged in. Now we actually have to figure out what that is. So this is not acceptable as an answer, all right? You have to actually compute this out. And what I want at the very end are 2 decimals. I'm going to want you to use your calculator and give me 2 decimals. So let's continue with this. Here's the part that messes people up the most. I want you to do this if you're not comfortable with the quadratic formula. I recommend you just ignore everything, including that minus sign. That one right there, just cover it up. And just do those 3 numbers times each other. 4 times 2 times 2. All right? And what is that? 16. Okay, so now what I'm going to do is rewrite this. 7 plus or minus the square root of 49 and what did we say? Minus, right? We had covered that up. And that right there was 16. And then all of that over, let's go ahead and do 2 times 2 is 4. So you're asking, can you use the formula, right? I'm saying, yes, you can. But there's a catch to it. The catch is this. You got to get it right, okay? You can't make mistakes in here because the formula is there. It's a gift, okay? It's a gift. It's like, here it is. You don't have to do any work except plug numbers in. That means all your arithmetic needs to be right. All right, so this number right here, 16, if you get that wrong, it's basically wrong, all right? So you want to become very proficient with this if you're going to rely on it. Okay, 7 plus or minus, what do you think I'm going to do next? I'm going to do 49 minus 16. And 49 minus 16 is what? 33? I don't need a big old root anymore. 33, and then all divided by 4. Okay, what do you think I'm going to do next? Put it into the calculator. It's time for me to figure out what the square root of 33 is. So 7 plus or minus. Now, what is the square root of 33? Approximately what? 5.17? Good enough? So notice on my next line, is that right? 5.7. Yeah, I was going to say that didn't seem right. 5.74? Okay. Good with that? All right, so notice from this line right here, from here to here, no more square root, right? The square root is gone. I went to my calculator and figured out what the square root of 33 was. For some reason, a lot of students, more than you would think, rewrite this and they put the square root back on there again. I just think they just forget what they're doing. But there's no square root. We've taken the square root of 33, it's about 5.74, and then divide this by 4, right? So what now? Yeah, so now you do not want to divide by 4 until the very end. That's the last thing you're going to do is divide by 4. So right now, here's what I'm going to do. See this right here? This is equal to, here's the way I like to do this. I like to look at the plus and the minus separately as 2 different answers. So I have the plus and minus. I'm going to consider both cases, right? First, let's look at it as a plus. If I do it as a plus, I do 7 plus 5.74, and then I'll divide that by 4. If I do the minus, then it's 7 minus 5.74 divided by 4. You see what I'm saying? I'm actually at this point splitting it up to get my 2 separate answers. So when we take 7 and we add to it 5.74, we get 12.74. And then we're going to divide that by 4. 3.18. Okay, and this is approximately, but I'll leave it as equals. Whoa, and then that other one, I've got to do 7 take away 5.74. So that gives me 1.26. And then divide that by 4 on my calculator. 0.315 or 0.32. I don't care how many decimals you round this to. Well, I shouldn't say I don't care. I want you to go at least 2 decimal points, all right? So if you want to round that to 0.32, you can. So we have 2 answers, don't we? So that means if I take that equation, 2x squared, what was it, plus 2 equals 7x, that was the original problem, wasn't it? If I replace this x and this x with 3.18, then this should be pretty close to true. If I replace this x with 0.315, it should be pretty close to true. All right? We have found 2 solutions using the quadratic formula. What do y'all think? Quadratic formula? I know a lot of you have seen it, but there it is. Well, you have to memorize the quadratic formula. Nah, this is 13, 14. The song for it, there's lots of different things to remember. Yes?
So on the test, you're going to make this factor, though, right? So we know that we can do it.
Yes, because on the next test, there will be a section on factoring. and then there will be a section on solving equations. So you cannot use the quadratic formula. You cannot use it if I give you an expression to factor. So if you're, in other words, if I asked you, if I gave you this, and I said factor, see, there is no equation. So you're not trying to find solutions. You're actually trying to factor it. And therefore, you couldn't use the quadratic formula. So that'll be part of the test. So you can't, there's no way to get away from the fact that you're going to have to be able to factor with that little x thing. But when it comes to solving the quadratic equations, we will have this in our toolbox. All right? Okay, let's take a look at another one. Okay, yeah, I've got one for you. How about this? Ready? Solve four x squared. Sorry. Minus 12x plus 9 equals 0. Is that a quadratic equation? Okay, is b 0? No, b is not 0, so we are going to have to go through and it's either going to be factoring or the quadratic formula, right? So do you want to go right to the quadratic formula? Yes, y'all do? Okay, we'll go right to the quadratic formula then. If you're going to do that, first thing you need to do is identify a, b, and c. So what's a? Okay, what's b? Negative 12. What's c? 9. Okay. So now we just go to the formula, which, remember, I will provide this for you. So I'll give you that on an exam. So what will we have here? X is 12 plus or minus square root b squared. Negative 12 times negative 12, 144. And it'll always be positive no matter what. This corner right here of this root will always be positive. 144 minus 4 times two numbers. What are they? 4, 9. Then all of that over 2 times 4. Now what did I tell you to do next? Yeah, don't look at anything except what's happening out right after that negative sign. What do you get there?
144.
What is it? 144? You get 144. That's kind of weird. You get 12 plus or minus square root of 144 minus, and then you said those three numbers multiplied is 144. And then all of that over 8. Okay, and so what is 144 minus 144? 0. That's kind of weird. So you're getting this. You're getting 12 plus or minus the square root of 0 over 8. What's the square root of 0? 0, right? So you're doing 12 plus or minus 0 over 8. And that means I don't need to look at two cases because 12 plus 0 is the same as 12 minus 0, right? You're not doing anything. You're not adding or subtracting. So isn't this just 12 over 8? Right? No? You don't like that? Why not? Oh, you can simplify it. Yes, you can simplify. You can reduce this fraction. 4 goes into both of those. 3 halves. Or if you like, 1.5 if you want to get a decimal. Right? We only have one answer. I thought we had two. I thought we always had two. No?
Either just go positive.
Yeah, so take a look at this. I want you to see. Now, everyone wanted to use a quadratic formula, but look at this. If we had done this, what number would go here? 36, right? That's this times this. And the number here, negative 12. What two numbers multiply to be 36 but add up to be negative 12? Negative 6 and negative 6. And so if I went and redid that problem, rewrote it, it would have been 4x squared minus 6x plus 9 equals 0. Y'all know what I'm doing here? I would have split it here. I would have factored out a 2x here and been left with 2x minus 3. And then over here I would need 2x minus 3. So I would pull out a minus 3 again, because this would give me negative 6x and this would give me positive 9. And so now it would be 2x minus 3 times what? 2x minus 3 again. And these are identical, aren't they? And so you set each one of them equal to 0, you're going to get the same answer both ways. You're going to get x is 3/2. So there is only one solution. There is only one solution to this quadratic equation. It is 3/2 or 1.5. So when it comes to a quadratic equation, you have x squared, right? What that means is that you can have at most two answers. It is possible to have only one. And it is possible to have none. So in the last example I want to do, let's look at an example where we would have no solutions, all right? So how about this one? X squared minus x minus 4 times a times c minus 5 equals 0. All right, so that's a quadratic equation, right? B is not 0, so we have to either factor or use quadratic formula. Factoring, let's just do it real quick. Factoring would be negative 5 here and negative 1 there, right? Negative 1 would be from this one, and then negative 5 would come from multiplying those two. Can you come up with two numbers that multiply to be negative 5 and add up to be negative 1? Don't think that's happening, right? Don't think that's happening. So you're left with a quadratic formula. So let's identify A, B, and C. A is, B is, C is. A is 1, B is negative 1, C is negative 5. We go to the formula. First number is what? Do I need to write it down again? No? Positive 1 plus or minus the square root of b squared. So negative 1 times negative 1 is positive 1. Minus 4 times two numbers. What is it? 1 times negative 5. So that's 4 times a times c, all over 2 times 1. Ah, crap. We're going to get two answers here. I don't know why I wasn't thinking about that. Should we get two answers, or do you want me to just fix it real quick? Fix it? I can do one quick little fix. Just change this to a plus in the problem. Right? If I change that to a plus,